Hello, welcome to Space Oddities. Thank you very much for being here. And I'm joined tonight by quite a lot of the normal panel. We're delighted, first of all, to welcome back Kareem after a long absence. How are you, Kareem? Are you better?
I'm doing much better, thank you. I
Good.
have a voice. I can speak again.
Yes, absolutely. Well, thank you for joining us. It's great to have you back. We haven't seen you in such a long time. And,
absolutely. Well, welcome again, Kareem. Hello.
Hi, everyone.
Nice to see you.
Good to
For
see
those of
everyone.
you who are not familiar with Kareem's constellation stories, he's got another one for you tonight, I gather. So we'll be hearing from Kareem a bit later. But it's wonderful to have you back in your rightful place, sir.
Thank you.
So there you are. Also joined by Roger. Hi, Roger.
Good evening.
How are you?
I'm fine.
Good.
Doing well.
Good as
Not
always.
getting out much in the night sky at the moment.
No. Well, never mind.
Rubbish clouds from Cornwall and Wales and stuff.
Oh, I'd complain to your MP.
I blame Lee.
Yeah. I'm also joined by Bernard. Hi, Bernard.
Hello, folks, everyone.
How's the weather in deepest Wiltshire?
As nice and sunny. Actually, it's a nice.
Oh, good.
Yeah, it's a nice winter at the moment. So let's hope it goes that way. It keeps that way.
It's been lovely and sunny here, and but it's been very cold. I mean, it's been down to -2, -3 at night, and there was we actually had some snow last week in Catalonia for about 5 seconds. But there was a fairly heavy snowfall on the Pyrenees, I noticed as I went out. And the Pyrenees were gorgeous, gleaming white in the sun. But it's all melted again now. So I don't think they're having a good season in the resorts in the Pyrenees at the moment. So we also say hello to Lou. How are you, Lou, all the way from the States?
Yes, greetings from across the pond. I'm still working on my good British diction, so bear with me.
Yeah, keep working on it. You'll get it in the end. And hi, Rachel. How are you?
I'm good. I feel a bit smug since we've got clear skies and Roger hasn't.
It might be clear out there now.
No, it's not fair. You deserve one night of cloud, Roger. Have a day off.
Oh, I've had more than that.
So anyway, thank you for being here. Mary, nice to see you. How are you?
Hello, I'm good, thank you. Just been looking at the comet because we have clear skies in Oxfordshire.
Oh, damn it. So just tell us, I think there's been such a lot of hype in the media about this comet that I think people are expecting something fairly large in the sky, but it's not a large object, is it, in the night sky?
It's not. I mean, obviously there are some stunning photographs out there. We've seen some in our gallery, but comets don't look like that to the naked eye. But actually, even with the gibbous moon, I was able to see it in my 8x42 tiny binoculars tonight, and it's a pretty decent sized smudge. It is just a grey smudge that looks a little bit like a Pac-Man ghost to me. I like to see things in abstract shapes.
Absolutely.
So yeah, it was really obviously kind of. It's not a star. It's a really obvious misty patch of sky. So if you go where the pole star is and just kind of look out from there on the star maps and star hop your way to it, and you can't miss it really through binoculars if you put it in the right direction.
Yeah, and of course on February the 2nd, at its closest approach to the Earth, it will be just to the right of Polaris. So it should be fairly easy to track down if you look at that area of sky. So good luck, all of those of you hunting the comet. We do appreciate you being here, and please, if you get any photos of the comet, do send them into the gallery. Rachel will put the details in the chat, and we'd love to see your images of the comet and hear about your experiences, which you can also put in the comments. In the comments. Very easy to confuse those two words, especially when you're dull. So. On a packed show tonight, we've got Lou, who will be carrying on with his history of the exploration of Titan, which we've all been looking forward to. Unfortunately, we didn't have time last week to include Lou's presentation, but Lou will be carrying on, and this week he's going to be talking about what Cassini, the legendary and much missed space probe, discovered about Titan. And Bernard will be talking about a story of 2 images, which is intriguing. So we'll wait and see what that's all about. And we've got the usual news and whatever. Kareem will be giving us one of his fabulous constellation stories. So we shall look forward to that as well. So in time-honoured tradition, what we're going to do now is to hand over to the man with his eye on the night sky, which is more often than not clear. That's what it says here. And all the way from sunny Sparkford, looking very smug there, as always. It's Roger with the story of what's in the night sky this month, Roger. So what have we got coming up, Roger?
Well, obviously, we'll be looking at the comet, which I will do in due process. Right, okay, so the 30th, and now we're going into February. So here we go. And obviously, by next Sunday, we're up to a full moon, I'm afraid. So boo-hoo to that. And this is what it's looking like at, well, it was looking like that when it was daytime, but this was today's phase of the moon, 70%. And just after sunset, we've got, this is just an iPhone picture of Venus setting and Jupiter up above it. So 2 nice bright objects down in the
Beautiful.
Down towards the western horizon now.
And just done with an iPhone. Very good.
Yes. Right. So we have still got the comet, which will be getting to its brightness in a few more days, and this is the path that it's currently taking. It's in Ursa Minor at the moment, and it'll be going through into Camelopardalis and then into Auriga later on in about another week. But that's what we've got there. And this was an image of it taken by me a few nights ago. I've sort of stacked a static picture of the background there and then put the composite amount of time on the picture of the comet over the top, which gives you quite a dramatic picture of the anti-tail and the tails following behind it. So
that's incredible. It's absolutely
Isn't that a wonderful image?
Yeah, amazing.
Yes, it's
submit it to Rachel.
It's nothing like that when you've taken individual, but when you compact dozens of pictures together, you can certainly get the clarity of the tails coming out quite nicely. But obviously, with it becoming so close on the 1st of February, we're going to need shorter exposures, otherwise you'll get the motion of it moving too much. So we'll have to raise the sensitivity, ISO, and the gain up to reduce the exposure time as well, to stop it absolutely whizzing by.
That's quite a remarkable image, Roger. That is.
These were obviously stacked. They were 5 minutes of 1 minute images stacked together, and then these were then stacked together afterwards, and then separated out from the background, and then put into a static background as well, just to give you a more clear picture of where it was in the night sky at that point, without all the blurred star trails as well. Right. Okay.
Somebody's just asked about the anti-tail. Does anyone else want to explain that, or shall I go?
Go ahead, Mary.
Yeah, go ahead.
So you probably remember seeing Roger's time lapse of the comet last week, and you could see that the comet is moving not the direction that you would think looking at the tail. The tail is sculpted by the solar wind, so the tail always points away from the sun, but the comet is actually moving towards its own tail. So as it's moving in its orbit, it's leaving behind a trail of dust. So it kind of overtakes itself almost. So what you're looking at there is dust that the comet ejected like a week ago, and the comet has now moved, and so just the way that we're viewing it, it makes it look like it's kind of gone backwards on its own dust tail. So that, in very simple terms, is what's going on. Obviously the comet is moving, it's rotating, it's moving curved in its orbit, and it's changing its position relative to where we're looking at it from. So there's a lot of complex movements going on, but the anti-tail is just a line of sight effect. So I hope that makes sense.
Yes.
Yes, it does. Thank you. And can I just say, Roger, without wishing to make your head so big that you can't exit the door, that has to be the best image I've seen yet of this comet, definitely.
I mean, unfortunately, I can't get a wider field of view unless I use my DSLR camera, because I seem to have quite a small sensor on the telescope, and it seems to be quite a narrow field of view. So you won't get the full length of the tail, unfortunately, with my images. I just want to try and get the anti-tail in as well. So, but
can you make a
we'll
mosaic?
see how it goes further on in the next week or so with the tail.
Yeah. And there's a very bright nucleus, isn't there? You can see that very clearly.
Yeah.
I was going to ask, do we have the size of the nucleus now? Do we know how big this comet is?
Don't know, actually. That's a good question.
I'm sure there are measurements of it, but I'm not aware of the actual physical size of the core.
Yeah, I've gone on Wikipedia.
Knowing how many degrees of sky it covers doesn't help you, because you need to know the distance as well.
Yeah,
how far away it is at that point, don't you?
I wonder if any of our viewers has read or heard how big the comet actually is. I could put it in the chat for us.
I mean, they're bigger than you think. I mean, the tails can be literally millions of kilometers.
Yeah, they can, can't they? Yeah,
they're really huge. Yeah.
Yeah. So yeah. So if anybody in out there watching us knows the physical dimensions of the comet, please let us know. Because I think just as a comparison, I think Halley was 16 by 3 by 9 kilometers, if I remember rightly. So it'd be interesting to see how big it is. Anyway, Roger, sorry, carry on.
Anyway, this is its location as of this evening. So it's basically between Ursa Minor and Camelopardalis. So it should be fairly easy to see once you've got the binoculars out and see this fuzzy blob as described by Mary.
Yes, and Andrew in the chat says it's around 1 kilometer across, so not a big one.
All right.
Yeah,
Thank you, Andrew.
Thank you. Small. Thank you, Andrew.
Yeah.
Okay, so here we go for positions of the planets, and obviously we've highlighted the comet there. Although at the moment, which is quite interesting, where we've got the Pleiades and then the Moon, and then we've also got Mars, all in a sort of a conjunction alignment this evening. So Mars and the Moon and the Pleiades are sort of all fairly close together up in the night sky, which is quite an interesting view to look at, providing you've got the clear skies.
Absolutely.
So that's quite good. So as you can see, now, as it obviously progresses through to its near Earth encounter, we're seeing it gradually shoot more and more across the night sky. And hopefully,
Roger, when will it go through constellations that we can pronounce? Will that happen?
What, like Camelopardalis and stuff like that? Oh, it's some of the Arabic and other names of stars that can tongue twist a few people, I'm sure.
And don't forget, with the names of the stars, if a name of a star begins with AL, like Aldebaran or Altair, then it's an Arabic name. Just so I throw that in.
Obviously, quite interesting. We've got the comet on the 5th, next Sunday, where it's going to be in the region of Capella, Alpha Auriga.
Oh, yeah.
So that could make an interesting composition in the pictures.
Absolutely.
Might be just in time for a gallery picture there, possibly.
Possibly, yeah.
Possibly, if not the week after. Right. Okay. So we have some new information from the James Webb regarding a Centaur object, which is like a bit like a rock, which is located more than 2 billion miles away between the orbit of Saturn and Uranus. It's called Chariklo, and it's 160 miles in size. And the James Webb seems to have observed that it's got some rings around it. So that's an interesting find. And this is the observation of the occultation of the rings here, which I believe it was in front of a star when it passed through. And obviously noticed the dips either side when it passed to realize that it had a ring system on it.
Amazing.
And from the observations, it's obviously a water ice combination on the ring system, which is no surprise, is it?
No, it's not a surprise, is it?
No.
Nothing more interesting there than plain old water ice, unfortunately.
Mm.
Yeah.
And here's a vague artist representation of that object.
But the fact that it's a centaur, that it creates an atmosphere when it gets close enough to the gas giants and the sun is what's amazing, because that might even be feeding the ring system. We're not sure.
Mm.
Yeah,
that's correct. Am I right to say that this is the biggest centaur that we have observed so far?
Yes, it's the biggest of, I believe there's like 10,000 or something like that, but this is the biggest one.
Yeah, 160 miles isn't to be sniffed at.
No, absolutely not.
Mm. So, yeah, so that's all I can represent for this week's images from the James Webb and my update for this week.
Thank you very much, and don't forget, it just shows the exquisite sensitivity of the James Webb Telescope, that it can detect those rings from such a distance. It's absolutely amazing stuff. So there we are. So Chariklo, interesting object. Now it's even more interesting. It's got rings apparently. So that's great. While we're on the subject of the James Webb Telescope, I'm afraid I have some bad news to share with you. And that is to say that one of the instruments on the James Webb has died, apparently. And this is the nearest. This is one of the spectrographs on the James Webb, the one that is used to take spectra of the atmospheres of exoplanets. And it died 2 weeks ago. And basically it wasn't responding to communication from the Earth, and they've been trying ever since to get it back online, and after 2 weeks they haven't managed to. So this is extremely depressing, because if they don't get the spectrograph back up and running again, the James Webb will not be able to take spectra of the atmospheres of exoplanets, which we've all been stunned at seeing so far from the James Webb.
NIRIS, along with the guidance system, were both built here in Montreal at University of Montreal.
That's right. They're Canadian. Yeah.
And it's important to note that MIRI had stopped communicating for, I believe, 2-3 weeks as well in the fall, and then managed to get up and running again. So there's still hope. But
there's always hope. Yeah, absolutely. If anybody can do it, those guys can. So this is just showing you here where it's located. It's on the Integrated Science Instrument module, at the sort of the back of the mirror, if you like.
I was at a conference this weekend, and one of the James Webb researchers from the University of Montreal was saying that they have gotten exoplanet atmosphere data for, I believe, 5 of the 7 TRAPPIST-1 system exoplanets that they were looking for between the 4 groups that were studying it. And they got a couple of transits for each of them, but they're still waiting for transits of, I believe it's either D or E. And they're hoping that they can get NIRIS up and running again.
Oh, well, let's hope so. Kareem,
if the instrument is really offline, and we're just going to blame you, right? Because
Of course.
Yeah,
I coughed.
yeah, you'll be the fall guy for that, without a shadow of a doubt. So, also in December, the whole telescope was offline for 2 weeks because it kept going into safe mode. And I hadn't realized this, that the James Webb was actually not working for 2 weeks in December. And they tracked it down to a software problem with the attitude control system. And they fixed it and they've patched it, and it's not going to happen again. But it just makes you realize that, it's such an extraordinarily complex beast, the James Webb Telescope, that, these things do and will happen, unfortunately. So let's all keep our fingers and legs crossed that they can get NEAREST back online so that we can continue to get spectrograms from the atmospheres of exoplanets, and in particular the TRAPPIST system that we're all so anxious to find out all about. Kareem, I did read, and I don't know how true it was, that preliminary analysis of the planets that they have examined don't seem to show any traces of atmosphere. So
not for the 3 that were published already, but 3 of them still haven't been published.
Yeah, that's right.
Working on those.
So that will be interesting to see.
But that was actually expected, because they're not all in the Goldilocks zone, even though they're all relatively nearby and good planets to look at. The idea of where we're going to have a stable atmosphere is still a question mark.
Yeah, indeed. Let's wait and see what happens. Okay, let's talk about something more cheery. There was a fantastic event last week, which was the wet dress rehearsal of SpaceX's Starship and Super Heavy B7 booster. Here's what it looked like. This was taken from a SpaceX drone. So this is a SpaceX video of the wet dress rehearsal. What happens in a wet dress rehearsal is that they completely fill the Starship and the booster with fuel and do a mock countdown to just before the point where they would ignite the engines, but obviously don't ignite it. And this is just to test that they can fuel everything, and all the piping and tubing and all the control systems, and everything works. And I think, much to SpaceX's surprise, it worked perfectly. And the next step will be the full 33 engine static fire, which we expect. I think it may happen tomorrow, actually. There's a road closure scheduled for tomorrow at Boca Chica. So keep your eyes open tomorrow for this momentous test of the Starship, the first full 33 engine static fire. And that will be something well worth seeing. So keep your eyes posted, ears and eyes posted for that. Here's a lovely photograph taken by NASA Space Flight, I should say, not NASA Space Flight. An amazing photograph taken during the wet dress rehearsal. You notice the booster and the Starship are white, and that's just ice. So the whole of the exterior of both the booster and the Starship, apart from the bit that's got the thermal protection tiles, is covered in ice from the cryogenic fuels. An amazing image. And here's another one from SpaceX, which I think is a lovely image taken by a SpaceX drone of what was happening with you can see the whole ground is shrouded in vapor from the cryogenic fuels. So that's a lovely image. And then what happened afterwards was that they destacked the Starship. They removed the Starship from the booster, took it back to the build site, which you can see in the distance there, for final preparations before this first momentous orbital flight, or an attempt at an orbital flight. And you can see that this is how they did it with the chopsticks. And again, for us of a certain age, this is just something out of Thunderbirds, the way that they did it. And there we are. And why is this important? This is important because the thing is that NASA have contracted SpaceX to build the lunar lander for the Project Artemis, the project to take humans back to the moon. And it's a lunar variant of the Starship. And this is an artist's impression, obviously. This is what it might look like on the surface of the moon. And it's a version of the Starship which has a bit of a different design. And NASA recently said that SpaceX are on target to actually get this built, so everything appears to be going well there. And this is why this first orbital attempt of the Starship, which should be coming up in in the near future. SpaceX are saying late February or early March for the actual first orbital attempt when they've got everything ready. This is why it's so important, because without the Starship flying, we will never see scenes like this on the moon. So this orbital flight attempt is incredibly important for the human return to the moon for SpaceX, obviously, and they've got to make it work. So there we are. So exciting times for SpaceX there. And there we are. That's just a bit of news for you.
Is it me, or it feels like we're living in a science fiction film now?
Well, as I said, it's pure Thunderbirds to me, and it's amazing. It's amazing, and what SpaceX are managing to do in terms of engineering and innovation. I mean, nothing like this has ever been done before. And when you think that combined booster and Starship, 120 meters tall, the most powerful rocket ever built. That's going to be amazing when that takes off. It's going to be truly amazing. So we do live in a science fiction film, Bernard. Never thought we'd see things like this. So there we are. Okay. Well, how are you all doing out there in YouTube? Hope everybody's okay. Thank you for being here. Don't forget, your likes and subscribes are very important to us. So if you haven't yet, please do hit the subscribe button, hit the like button, tell all your friends about us. Go out in the street with a big placard. And that guy who has the golf sale placard in the street, get rid of him and stand there all day with Space Oddities and our address on, because we would like to get more viewers for our programs, because we like to think we put a bit of effort into them. So spread the word if you'd be so kind, and thank you very much for doing that. And yes, Rachel says please keep the thumbs up below the screen too. Very, very important. Do hit that thumbs up. Okay, well, moving on. I think next on the agenda for this evening, it's Bernard, and Bernard's got something intriguing to talk to us about, I believe. What's going on?
Yeah, thanks, Andy. So basically, this is going to be more. I'd like to have a panel conversation about what I'm going to present. So let me just quickly talk through just a few slides. I don't have very much, and then I'd like to have your point of view on this. Basically, I've called this the tale of two images, and this is generally how I finish some of the presentations I do. So if you recall, my last book is on the imaging instruments that were on board space missions. So it was the evolution of space missions, cameras, and instruments, and in there I discussed the story of what happened in November 1935 in South Dakota in America, where two brave men from the U.S. Army Corps, Captain Stevens and Captain Anderson, lifted off from this giant helium balloon named Explorer 2. And their daring mission was to reach the stratosphere, and at the time it was unexplored territory. And they managed to reach 22 kilometers in altitude, and they did lots of studies there, thanks to 64 scientific instruments. Now, luckily for us, they also took a very, rustic, I'd say, camera. Nevertheless, and with that camera, they managed to take this picture. And this is, while it is not the first picture to be taken from space, sometimes you might see that on the internet, because the first picture to be taken from space, you have to wait until 1946 when we managed to go above the Kármán line. But it is the first high-altitude photography. And it sort of shows the curvature of the Earth. And this is like really the first time you can see that on an image. And it was great because, the 96% above the Earth's atmosphere. And it was just an incredible view. And the interesting thing about this is that, this was, so again, in 1936, and it was a record-breaking flight. And a journalist asked Captain Stevens afterwards, once they came back down, and they said at the time, what do you think is the feasibility of flying into outer space? Like, would we be able to do that one day? And at the time, he said, no, this is just impossible. couldn't really conceive this happening. And then I fast forward to 2019. So in 2006, we have New Horizons that was launched. As a reminder, New Horizons was a medium-sized planetary mission from NASA to go and explore Pluto. But also in 2019, it went to visit Arrokoth. So Arrokoth is this big, or relatively, Kuiper Belt object. So Arrokoth is like a ball of ice and with a bit of rock and dust, and it's at 43.6 AU from us. And that's, just a reminder, that's 6.5 billion kilometers away from us. And it took New Horizons over 10 years to reach it. Well, actually, more than that. And here's the intriguing thing. So it took this picture thanks to LORRI, which is one of the advanced optical instruments there. And it took this high-resolution shot that's showing a resolution of 33 meters per pixel. And, this was a breathtaking picture to take, because at the time, New Horizons was the fastest aircraft to be sent to the outskirts of the solar system. It's currently flying at 84,000 kilometers per hour. Arrokoth is relatively small. KBO, it's 36 by 20 by 10 kilometers in diameter. The low light situation was, incredibly low at 44.6 AU from the sun. And at the time, New Horizons has already been in deep space for 13 years. And this image is an incredible feat of science and engineering. And what I'd like to mention here is that when you take these two pictures side by side, I think I got messed up there. That shouldn't be the picture of that balloon, but anyway, you get the point. When you get the picture of what Captain took side by side from 1935 to 2019, that's only 84 years. We're talking about a lifetime. Within a human lifetime, we went from taking grainy pictures from the edge of the stratosphere to one of the furthest object we've ever been able to fly by, which is a Kuiper Belt object. And we often compare these dates, with the Apollo and before Apollo, after Apollo, about the incredible pace and change in technology and science and our understanding of space. But I thought these two images are also, a great way to remind us of how much we have advanced. So with this in mind, I wanted to ask the panelists, what do you think in 84 years from now, what would you think would be the most amazing picture we would take, or we will have taken by then? And or what would you like to have in terms of an image that would be sent back to us in 84 years from now? So there we go. I open this question or this conversation to the panel. Who wants to go first?
It's an interesting question. I can't honestly think. I mean, I would expect that we would have more images of Kuiper Belt objects, perhaps.
Well, I have some suggestions. If the panel is Andy, you can reopen the panel, the image to the panelists.
I'll take a shot. I want to see the first image from under the ice sheath of Europa. I want to see pictures of European fish swimming around.
Yeah, totally. That should be technically possible in 84 years from now. I agree. Yes.
Absolutely.
I'd like a direct picture of an exoplanet.
Yes.
And that should be possible
I can
too
dream.
with the Earth. No, with the Earth shots.
No,
the breakthrough space shot, right?
Yeah.
With the
and not just that. There's talk now of using the sun as a gravitational lens. Because apparently it does act as a gravitational lens if you were to place an instrument at its focus, which is about 40 astronomical units away. You can get the sun to act as a gravitational lens and thus greatly magnify things in the background. So there's talk about researching that. Obviously, 40 astronomical units is a hell of a long way away. But theoretically, it's possible. So
I would love to see one of our extrasolar probes look back at the Oort cloud and see what it actually looks like. If we could get enough light from other sources to get some resolution on what the Oort cloud actually looks like and the object distribution, it would be phenomenal to get some tangible evidence there outside of the long period comets. Michael Bryce said a confirmed exoplanet with Earth, and Chris Reardon was saying, Chris O'Riordan, sorry, first image of life on another world. So I think he wants something waving back at us.
I would settle for microbes on Enceladus. That's that, and or Europa, or both preferably. Imagine if we could find life on both Europa and Enceladus and compare them. Wouldn't that be amazing?
Add Titan to the list.
Add Titan to the list. Absolutely.
Let's go methane filled, yeah.
And possibly even Pluto.
I was going to say Mars, but Mars is always 30 years in our future. So I don't know if that just always extends or not, but presumably at some point. That's the official.
Incidentally, for those of you that like balloons, sorry. I love balloons. I really, really love balloons, helium balloons and hot air balloons. And there is an amazing book about Britain's first aeronaut, who is a guy called James Sadler. And nobody's heard of him because he wasn't an academic, but even though he lived in Oxford, he designed the balloons, he built the balloons, he flew the balloons. Such an incredible guy. And actually on one of his balloon flights with his son is the earliest recording of a glory seen from the air that I've found in any literature. But it's written by a guy called Mark Davies, who's a local historian. And if it wasn't for Mark Davies, I wouldn't even be talking about this guy now, because he's just been erased from history. And if it wasn't for Jackson's Oxford Journal, nobody would even remember that the guy was born. And he was a true polymath, but because he wasn't an academic, nobody was supporting his ventures. But the story of the stuff that he did in those balloons is just incredible, so incredible. So yeah, if you like balloons, that's worth looking for.
Fantastic.
Cool. May I add to that, Mary? We just had Jim Green, who had a remarkable career at NASA, running the Space Science Data Operations Center at Goddard Space Flight Center, head of the Planetary Science Division at headquarters, and then eventually NASA chief scientist. He just retired. But he was a Civil War enthusiast, and he was also a balloon enthusiast. And I remember a painting on his wall of a balloon used in the Civil War to scout out troops at a distance. And Jim, I believe this is the correct story. Jim went through the planetary decadal survey, what the planetary scientists say we should be doing in the next 10 years. And he mapped out which scientific achievements could be attained by launching instruments on balloons as opposed to spaceships. And I believe the number he came up with was something like 70 or 80%.
Wow.
Which would be remarkable when you consider the cost of launching anything into space. So balloons are not just ancient history.
No.
And we've had a few discussions about seeing pictures taken on the on the surface of a planet or underneath the ice crust. We are seeing, sedimentation in layers of rocks on Mars to such high degree of detail that this is well within our scope right now. We don't even have to wait 80 years.
No, absolutely. Yeah. And talking of balloons, one book that I greatly enjoyed was George Smoot's book, which I can't remember the title now. Whispers of Creation, I think it was Whispers of Time. Anyway, it's his account of Kobe, the cosmic background explorer that made those maps of the cosmic microwave background. And he was launching balloons from all over the place, from Antarctica, from the States, with instruments on to try and get that first image of the cosmic microwave background. And some of the stories in there are just absolutely priceless. And he lost one balloon, came down in the jungles of South America and was promptly held to ransom by the locals, and stories like this, and that's a fantastic book to read. I will get the title right in a moment. I haven't read it for a while. I'll just reach up to my bookshelf in a moment and drag it down. But yes, I mean, balloons are still incredibly valuable things for scientific research. They really are. People do tend to think of them as an archaic means of acquiring data, but they're not. They're still very much alive. So there we are. Right, Bernard, what about you? What do you think?
Well, I just want to say thanks, everyone, and to our viewers. Yes, if you do have any other ideas of what you want to do, feel free to put it in the comment section. For me, I think I'm really hesitating between either what Lou mentioned, which is a picture of the subsurface oceans of Europa or Enceladus with potential life if we're lucky, or a surface feature of an exoplanet like Proxima Centauri B, the closest exoplanet that we might be able to reach with the breakthrough Starshots program that's planned to send a very small light sail microchip towards it. That would take 40 years to reach. So 1984, 2084 is 2084 is not that undoable. So yeah,
no, that's right.
Exoplanet surface feature or underwater subsurface. There we go.
And don't forget as well, Bernard, that the most interesting or impressive scientific image may well turn out to be one of something we know nothing about at the moment. Because
very good. Just like what I just didn't want to interrupt you. Just like what Captain Stevens said. Like he said, we're never going to go to space, and then
exactly. They had no idea of the existence of the Kuiper Belt then, and have a Kuiper Belt object in such detail. Well, a Kuiper Belt object at all. They had no idea such things existed. So it may well be, after another 84 years, that the most interesting image is something we can't even dream of at the moment.
Very, very good comment. Yeah, absolutely. Well, thank you very much. I thought it was
thank you. That's really interesting. So it's a very good question to ponder. And we're going to stop pondering now. We're going to go over to something incredibly dynamic, interesting, and always fascinating. So I'm going to hand over to Lou now, who's going to continue with the story of Titan. Are you not, Lou?
I am. Let's see. Do we have? Can you bring that up?
Oh, sorry. Sorry, I didn't mean to do that. I meant to do
that.
There we are.
Okay, there we go. So thanks again to everyone who has hung in there with our story of the exploration of Titan. We started with some ancient ideas about life elsewhere beyond the Earth, some of the first very early observations of Titan showing that it had an atmosphere, Pioneer mission that flew by Titan, and then last time we talked about Voyager. This is going to be a two-part on Cassini. There's just so much to talk about regarding the Cassini mission to Titan, and we'll talk about the spacecraft and its mission and the Huygens probe today, and then next week we will talk about the data and discoveries made by the orbiter. So let's get to it. Let's see if I can change slides. Try again. There we go. All right, so 1997, that was 20 years after Voyager, so 20 years of new technology. The Cassini spacecraft lifted off from Cape Canaveral, and it began its 7-year journey to Saturn. Here we go. What you see here is the flight trajectory. There were 2 Venus gravity assists and 1 Earth gravity assist, as well as Jupiter. And I remember that when Cassini was going to launch, the I don't remember which, I think it was Greenpeace, was sending boats out into the Atlantic Ocean to try to keep the mission from launching because it had a nuclear power source, was going to have an Earth flyby, and they were afraid that somehow the spacecraft would re-enter Earth's atmosphere and cause radiation destruction all over the place. If you knew how hard the plutonium-238 nuclear source was baked in, you can put dynamite around it and explode it, and nothing would happen. So anyhow, I stopped contributing to that.
Don't they drop the RTGs out of planes to test how durable they are? I think I read that somewhere.
Oh, maybe I hadn't heard that.
Yeah. I think they dropped them out about 10,000 feet or something and see what happened. And of course, they're absolutely fine.
So it's quite safe, but there were no such incidents in either event, and so there was a Jupiter swing by in December 30th of 2000, and then orbit insertion on July 1st of 2004. Here we go. So there were many kind of first and just an incredible amount of data returned, and just this enormous mission that had 2 extended missions added to its original mission. So it spent in total 20 years in space, 294 Saturn orbits, and you'll see many of them were devoted to the observation of Titan. And as you see here, 453,000 images. Just remarkable.
Amazing, isn't it? 453, nearly 500,000 images. Wow.
Yep. And I am having a little, as always, let's see if I can bring my screen back here. There we go. Okay. So I mentioned...
just to mention that all of those images are publicly available online.
That's right. The American public has paid for all of this, right? Because it's a government program. And so they're all available to the public internationally.
Yeah.
So here you can see the plan of the objects that the Cassini orbiter was to fly by. And what you see is over on the left, this is kind of a time series. You see the prime mission, the equinox and solstice missions, which referred to the seasons on both Titan and Saturn, since they're gravitationally locked. The Huygens probe descended into the atmosphere of Titan quite early in the mission. And then you can see the number of flybys of Titan up here by year. Titan is such a fascinating object that it dominated the science objectives of all the other moons put together. So let's see. There we go. So just a little bit more of Cassini by the numbers. You see the images taken, as we already talked about, 162 flybys. It discovered 6 moons. Had at the time, and this is of course, this is actually a bit of an old image. At the time, 4,000 papers in peer-reviewed literature that referenced the Cassini discoveries. And and I think what's most impressive here is in the lower left, 27 nations partnered together as science does, kind of melting the boundaries between people and cultures and countries to make this mission a success. Okay, here's just a diagram of the Cassini orbiter, and again today we're going to focus on the Huygens lander, but as kind of a preview here, you can see the magnetometers, infrared spectrometer, which was called SEERS, composite infrared spectrometer. The radar instrument, which did active radar not only of the surface, but something called radio occultation, which I'll explain probably next week. Radio and plasma wave science instruments and plasma spectrometers and magnetometer imager. These are the fields and particles instruments. Imagers, of course, narrow and wide angle imagers, and ultraviolet spectrometers. So when you send something out to the outer solar system, it costs this much to get it together and launch it. You're going to load this thing up. And this was really a full court press, not just for the Saturn system, but as will become very evident for Titan as well. Yeah, there we go. So this is an artist's conception, obviously, of the Cassini Huygens lander that has now been released from the Cassini orbiter and is going to aerobrake and then parachute its way down into the atmosphere of Titan. And of course, once again, what we're seeing in that picture, even though it's an artist's conception, is the aerosol haze shrouding the surface. This is an example of the instruments on the Huygens lander. We can see the HASI, the Huygens, maybe it's Huygens, I'm not sure, atmospheric science package. Down below, you can see the GCMS, the mass spectrometer, and the ACP, the aerosol pyrolyzer inlet. That actually, the pieces of the atmosphere went into that inlet and got sent through a pipe to the mass spectrometer to see what it was made of. The SSP is the surface science package, which not only characterized the nature of the surface, but also the surface atmosphere. So here again, you see just a tremendous array of instruments and instrument packages meant to assess the nature of Titan at that latitude and longitude. So we need to keep that in perspective. Here we are with the just a kind of general sequence, landing sequence of the Huygens lander. It had a heat shield, so you aerobraked first, slowed down enough to release its initial parachute, then dropped its heat shield, secondary parachute released, and then landed in what it turns out, because of the surface science package, was a kind of not rocky hard, not liquid, but kind of a marshy area. And we were prepared because we had done the atmospheric modeling, and we knew what was precipitating out high up in the atmosphere. Cassini was prepared and Huygens was prepared to land in any such surface, either hard, marshy, or completely liquid. Here is one of the first images from the downward imager on the Huygens lander. You can start to see here, of course, you can see terrain. But you can also start to see what we call fluvial channels, which I think we can say now are rivers of hydrocarbons. So this was a very exciting image as we got our first close-up looks of Titan. Here we see even closer in image. This is showing rivers clearly. It's showing the large gray area on the bottom, which is believed to be hydrocarbon lake, and then the white material kind of in the center of the image here, which is likely methane clouds. Methane clouds, subject of great debate before, even after Voyager and before Cassini. And that was resolved before Cassini, I think. But there's observational evidence. So here we have first image on the ground. You can see what appear to be rocks. These are quite likely ice that's frozen solid at 95 Kelvin temperatures. You can see some estimates of their size. The middle picture here is colored. That's a false color, but what we believe the coloration would look like, with the atmospheric haze, the precipitation, the tholins, hydrocarbons, and nitriles precipitating out, falling down over the rocks, over the probably ice on the surface. And you can see some smooth areas here, which we believe are pools of liquid hydrocarbons. Just a fascinating, I mean, can you imagine 1.5 billion kilometers away and able to get a picture of the surface of this? Remarkable.
Yeah. It's amazing.
And I am going to stop here. This would be the first image, a radar image from the orbiter. But I think I'm going to save the amazing discoveries from the Cassini orbiter for next time, and when we revisit the exploration of Titan.
Thank you very much, Lou. That's absolutely wonderful. As you say, Cassini discovered a lot about Titan. Where would we have been without Cassini in our exploration of Titan? And the Huygens probe, the European probe, which landed, and then never forget that day when it landed. And it actually took a long time to come down through the atmosphere, didn't it? I think. Because there were high winds in the atmosphere. I think it took well over an hour from the top of the atmosphere to when it landed. And somewhere on the internet, there's a sound recording that it recorded as it was descending, and where you can hear those winds. And there's a full animation of the descent of Huygens somewhere on the internet as well in real time. So lots of information about Cassini and Huygens on the internet, definitely.
Isn't it?
So,
isn't it
because
ironic?
we were able to track the Huygens as it parachuted down, we were able to, through Doppler measurements, we were able to get wind speeds.
Yes, absolutely. And I think, if I remember rightly, the wind speeds were surprisingly high, weren't they? I don't think they were expecting such high winds. Anyway, thank you very much, Lou. That's great. We look forward to continuing the story of Cassini at Titan next week. By the way, I'd just like to say before we go any further, we're sorry to Daz. Daz was with us before the program started, but his internet connection is not good, and when more panel members turned up, Rachel and Mary, they booted him off, unfortunately. So Daz, we wish you were here with us in person, but we see you in the chat. So anyway, you need to get on to BT, mate. You need to give BT hell about the state of your connection. You really do, so that you can be with us all the time and not just when the vagaries of BT allow you to be. Anyway, we're going to move on now. And we're delighted to welcome back our friend Kareem, who's been absent for far too long. And it's great to have you back, Kareem. And I must say, you're looking well, even though we can tell by your voice that your voice isn't quite there yet. But anyway, welcome back. And I believe you have got something to share with us. Although I don't see your presentation here. Have you actually uploaded it?
I did.
Right, you need to make sure you select it
from here.
Yeah, make sure you go back into where you uploaded it and select it to show it.
I did. I selected it to present. Do you see it?
Hang on 1 second. Yes, it's there now. I see it now.
Wonderful.
Great. Okay, let's have a look then. So what have you got for us then?
So I have an excerpt of Two-Eyed Seeing, and as some of you know who've been watching Space Oddities for a little while, or who joined in when I came by a few of the astronomy societies in the UK virtually over the last couple of years, I try to share a little bit of the seeing and the stories from ancient observations from across the world of some of the constellations, some of the features of the night sky, in a way that also acknowledges some of the modern scientific knowledge that we have about these different targets. And it gives us a chance to understand that the night sky really isn't just ours. It's been shared by people from all over the world. Let me see if this, yep. So I typically start all of my outreach with a land and sky acknowledgement. Here in the Montreal area, we're on unceded lands of the indigenous peoples, the Mohawk and the Algonquin. But we share the night sky with all of these different cultures as well. And right now, when we're going out and we're looking for the comet up in the northern sky, and we're looking at it as it passed between Ursa Major and Ursa Minor, when I talk to some of my friends in the indigenous cultures and we share our stories and we try to look with binoculars when we go out at night and try to see something like the comet, it's important to recognize that they don't call it Big Dipper, Little Dipper, or Ursa Major, Ursa Minor. They can talk about Muin and the 700 birds, or they can talk about the Fisher or Ochik. And using those guides gives them a better idea from their perspective, from how they've grown up, as to where this object is. And they have their own stories of comets and of other objects. We're also in the snow blinding moon at the moment, or the snow moon as the settlers called it. And it's kind of neat to recognize that the snow blinding moon is called that because when it's a full moon right around sunset and just before sunrise, because the moon is at higher altitudes in the wintertime, it's at such an angle that the light from the sun reflecting off of the full moon reflects off of the freshly fallen snow and ice on the rivers to blind us. And really, it was a precaution given to the hunters and the gatherers that went out during February, during those lean, hungry months, to tell them that you won't have clear sight because the snow will blind you. And the constellation that we most recognize with winter is the one that we call Orion. And it's called by the Ojibwe the Winter Maker because it stretches all the way from Procyon in Canada all the way out to Aldebaran in Taurus. And it really does encompass the entire southern sky when you go out at night in the wintertime, because winter is here. The snow is coming out from that little pouch. And the location of the little pouch on Wintermaker's belt is exactly where the Orion Nebula is, because we see that fuzziness of the nebula. And when my students go out and they try to take images of Orion and they try to see what they can see with their iPhones and with their DSLRs, they see that little bit of fuzziness, and they can even capture that with iPhones. Like you can see here, iPhone 10, iPhone 11, Chloe, Michael, Zach, they all were able to capture not just the full breadth of that constellation and Aldebaran over there in the corner, and even you can see Sirius in Chloe's picture on the left side there, but you can see that little bit of fuzziness around the Orion Nebula. And if you're able to capture that with a good DSLR camera and a telescope, and you can use an RGB filter, you can create an image like the one there from Maxim and Alex from a couple of years back. This is where we tend to stop in the introductory astronomy side, and we just dive into the Orion Nebula and the birth of stars, and we share those different ideas of how stars are born and what we've learned from even from Hubble being able to delve into some of those star-forming regions. But I kind of realized a few years back that I didn't really know the story of Orion. I mean, I know a lot of Greek mythology. I grew up with it in the States, where I grew up in Pennsylvania, and then in Guelph, Ontario. I would study, I would learn mythology because I found these stories fascinating. But Orion was one that, other than knowing that he was a hunter, I didn't know very much about. And when I started studying into who Orion was in Greek mythology, there's some conflicting stories. Homer refers to the shade of Orion that he came across, the hunter, but he refers to that separately from the Orion constellation that he already talks about in the night sky. If you trace through some of the stories, you see that Orion was likely the son of Poseidon, and as a result of having his father be the god of sea, he could walk on water, which meant that he could move from island to island. And unfortunately, he was a bit of a debaucherous young man, and he did horrible things. And so he got blinded by one of the fathers of a young woman who he had wronged, and had to get healed by the light of the first sun off of one of the most easternmost islands. Later on in life, he went to an island and hunted with Artemis. And then there's conflicting stories of how he died, but the general consensus is that he died from the sting of a scorpion because he bragged that he could hunt any object on Earth. And that's why if you follow Orion through the night sky, when Orion finally sets, it's because Scorpius is catching up and it's now above the horizon during that setting time. So there's a lot in the stories that tell you about the motion of these stars, even in the Greek mythologies. But when we look at the First Nations, we start to see that there's more captured in these stories than just the position of the night sky and the objects that are there. So I tend to talk a little bit about some of these stories, and you can talk about the Chinese with their protector General Sao. You can talk about the Hindu god Vishnu being both a protector as well as a arbiter of justice. That's why he holds the axe to strike down anyone who doesn't quite follow the teachings of the Hindu religion. But I really love talking about the one that I learned about in the Yolngu people in the Northern Territories of Australia, because they look at this reoriented Orion that they see in the southern hemisphere. And they see these three young men that have been banished into the night sky being chased after by the spirit of a sawfish that they caught and they devoured. Because a sawfish was one of the sacred fishes that the elders told them that if they caught a sawfish, they had to release it back into the water. And these three young men, it was the only fish that they caught, and they were hungry, so they decided to eat it. And as punishment, they were banished up into the sky. Now, when we start to learn a little bit more about the way in which ecosystems work, what we realize is that sawfish actually move along the shoreline, but in the water, up along the lowest part where they bring up some of the small fish and some of the small animals and some of the small proteins that can get caught in the sand under the water. And because they dislodge all of this material, it brings larger fish in closer to the shore, which results in the villagers being able to catch these larger fish and feed the entire village. And so by killing and eating one of these sawfish, these three young men actually were endangering the feeding of the entire village because the sawfish were sacred fish. But the question becomes, did they know that the sawfish served this purpose? And is that why, or was it because in years of not very many sawfish being seen, they were hungry? And in years where there were lots of sawfish coming in to those low shore areas where the water level was low, there were more and more fish that came close to shore, and there was just this connection being made. You can even look in South Africa, and in South Africa, they talk about the 3 stars, and the 3 stars in the sword are dogs, and the 3 stars in the belt are warthogs. And the dogs are chasing the warthogs, but while Orion is up in the sky, the dogs never catch the warthogs. And that's because during what we have as winter in the northern hemisphere, which is summer in the southern hemisphere, warthogs tend to have their litters, and their litters typically come in 3s. And so if the dogs don't catch the warthogs have their next generation being born, and now it sustains the entire community moving forward, because now you have that animal available to you to hunt for the rest of the year when you need to forage to make sure that you can provide for them in the wintertime. So when we look at a lot of these stories, we see that it relates to what's happening in nature. But that placement of stars is still incredibly vital. And when we look at something like Orion and some of the First Nations cultures in the US, it's incredible that during the fall time, the stories of Orion are all about Orion as the protector, the hunter, the one who keeps an eye over the entire tribe. But in the springtime, when Orion starts to set in the early mornings, Orion is actually seen not holding a bow and arrow, but holding a stick that can be poked into the ground to plant seeds to create the next harvest. So Orion switches from the start of winter as a protector and warrior to the end of winter, start of spring as really a symbol of the harvest, of planting seeds so that you actually have food to sustain the entire tribe down the road. So the placement of the constellation stars at different times of the year is captured not just in their stories, but also in petroglyphs, like the one here at the bottom right. So when we look up at the stars and when we look at the moon and when we look at the objects in the night sky and we remember that we're not the only ones looking at them, let's try to look at them with 2 eyes, not just one, so that we actually are sharing these stories and the connections to nature for the benefit of all. Thanks, Andy.
Thank you, Corinne. That's absolutely fascinating, as always. So thank you very much for that lovely story about Orion. And as you say, we naturally can only look at it through the eyes of our own culture and our own science and our own traditions. But we're not the only ones in the world, as you have always shown us.
I had the benefit this past weekend of doing a workshop for a bunch of students from across Canada, and we did the Orion Nebula processing workshop with RGB image files from our robotic telescope in California. And we were drawing out the details and we were talking about them. And then afterwards, when they came to chat with me, I told them the stories of the night sky, because we started with Winter Maker. And so a lot of them were like, wait, you're talking about the First Nations here in Canada. What other cultures are there? And the idea that every single culture that can see these star constellations have their own stories that relate directly to their own reality is something that just really is moving. And it kind of, it reminds us we're not alone when we go out at night. Even if we get cloudy nights like I get, if there's Roger out there enjoying the night sky and sharing it with us too.
I love how a lot of the stories fit in with the movement of the stars as well. I know the Iroquois mythology of Orion, it all plays into, like in the summer, the character is carrying the sun across the sky. And it's just beautiful the way that they all fit in with the movements and the positions of other constellations. And quite frankly, the Greek stuff gets on my nerves. I think they're all horrible people. They do horrible things. And I much prefer reading about the other cultures' stories.
Well, this is exactly it. I glossed over it, but every single Greek hero at some point commits rape or adultery or debauchery.
Absolutely.
It's just horrible.
Yeah, they didn't seem to be that in tune with nature, the Greeks, did they?
No.
Not really. It's all heroics and warriors and voyages and all that sort of stuff. But there we are.
It's important to recognize that that's how they remembered the stories, though. That's how they remembered the constellations. And this is where it's very particular to each culture. When I talk, when I do the talk about the Big Dipper, Little Dipper, and I compare the Greek story to the Roman story, which are almost the same, but those subtle differences tell you the role of the women in those two societies. And it just comes out crystal clear. That's what's so moving, is it really does connect to the way in which those societies evolved and what would stay with them.
Absolutely. Well, Kareem, thank you so much for that. I hope you will give us another constellation story very, very soon, because they are never less than absolutely fascinating.
And I have to say, some of our Montreal members are looking forward to Mary's workshop coming up in just over a week, but I'm going to be teaching at the time, so I'm gonna have to live vicariously through my friends.
Oh, okay, Mary, that's a good idea. Just before we finish off today with Rachel's wonderful gallery, would you like to tell our viewers again about your workshop?
Yes, so we're going to be doing a sketching workshop live on Zoom. We can't stream it live to YouTube, but we will try to record it. So if you can't attend, then you'll be able to catch up later. But basically, we're going to just go through an entire sketching workshop. So I'm going to teach you how to draw a deep sky object, the sun, some sunspots, and lunar craters. Step by step, I'll be drawing along with you, and it's always really good fun. And people that do my workshops always tell me they can't draw anything, and at the end of it, everyone has something that they love. So please join in. It's free of charge, and I promise you will enjoy it. And actually, I think it's really important that as astronomers, we all try sketching at least once, because it makes you see things differently. It makes you look at things differently forevermore. So I tricked myself that I was learning loads doing imaging, and the reality was I was learning nothing other than how to process an image. I wasn't learning anything about the object, the shape of the nebula, what the craters were called, what the shape of the shadows meant. I only started to get that knowledge when I started sketching. So yeah, 7th of February at 6:30. So children can join in, adults can join in. It's for everybody.
Fantastic. Thank you so much, Mary. And if you'd like to participate in the Zoom workshop, send us an email at spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. And we will send you the Zoom details so that you can join in. And we hope you do, because it promises to be a great event. As Mary said, unfortunately, because of the way that Mary organises the workshop and the technical things with Zoom, we won't be able to stream it live on our Space Oddities channel. But as Mary said, we hope to record it and we'll upload it to the channel later. So thank you very much, Mary. That's fantastic. And now, Rachel, how are you? And are you ready with this week's gallery?
I'm good, and yes, I don't know how I'm supposed to follow Kareem, but I'll try. But yes, if you can load it up for me.
Yep, there you go.
Thank you.
Make that a bit bigger so we can see the images. There we are.
Here we go. So we're starting off with a lovely image of Sirius by Lee. in Cornwall, and he always likes to give us a little bit of a funny story behind his. So he produced this effect by using a slow-mo cable continuously throughout the exposure. As it's such a disco ball type of star, I felt like throwing on my white flared suit and black shirt, medallion on my pigeon chest, to bust some moves and point in the air. I think
Yeah,
we did
I've heard that sort of thing
Kareem's
happens a lot in
stories
Cornwall.
and Lee's astrophotography stories. I think. So here's Lee's serious.
These are so much fun to do.
I think it just shows such the range of colour, doesn't it?
Yeah.
The colours are amazing in that.
So really nice. And I hope you had fun disco dancing, Lee.
Well done, Lee.
Then we've got one of the ISS by Sonia, which she took on Saturday with her DSLR, a 45-second exposure, and just used Google Photos to edit it to black and white.
Lovely image of the ISS. Well done,
She's got
Sonia. Yeah,
Sonia's training hard for the London Marathon at the moment, so go and give her a sponsor, guys, if you can. She's working really hard on her training.
Yeah, I'm trying to think what she is on social media to share her link. I think it's Sunset Twilight, is it? You might be able to find one of her links on there. Another one by Sonia. So this is a really nice one, which is Moon and Earthshine, which she took on the 25th of Jan. And it's one of her favourite that she's taken so far.
Gorgeous.
Oh, that's lovely. That's really nice. Beautiful Earthshine.
Really it looks like it's actually coming out of the globe. Like that's that's gorgeous.
It does, doesn't it?
You can feel the Terminator.
So to speak. Yeah, wonderful.
We've got one by Chris here, and I can't actually read because it says live over the top, but I know it's a level of some letters at the top, 14 and 15.
Yeah, 14, 15.
In the giraffe constellation of Camelopardalis, or as I like to say, Camelopardalis, because I think it sounds so much more fun that way. Which I don't actually think I've spent a lot of time seeing this image. So this was his first and only to date broadband target he's had a go at with his mono camera. And it's about 2.5 hours of luminance and 1.5 hours on each RGB filter, so 7 hours altogether. And it's a real...
Wow.
It just feels really cosmic, this one.
That really is cosmic, isn't it? Well done.
Don't know if it's just the color combination or something about it just feels different, but it's
reflection nebulae.
Nebulae.
Yeah, they just have so much depth in them. If you can actually this is gorgeous,
isn't it? Isn't it gorgeous? It's fantastic.
Make a great blanket, wouldn't it?
Yeah. And Lee's just commenting. Lee's commenting that he did bust some moves, but he also bust a hamstring. So maybe take it a bit easily. Then we've got one of M31 by Jerry.
Yeah, thank you.
Wow.
Are there on the screen?
Thank you, Gerard. That was the book I was thinking of. Wrinkles in Time. Thank you very much.
So, a lovely, huge Andromeda there.
Wow. Oh, that's amazing.
You can see there's so much detail in the dust lanes all the way around on this one. You feel like you can really pick it up like a frisbee.
Yeah.
It's got sort of all that depth all the way around.
It's amazing.
Really nice.
Really nice. Well done.
And I feel like we've got another one by Jerry. Yeah. So he's done the Orion Nebula and the Running Man Nebula.
Oh, nice.
Oh, wow.
Really striking.
So much drama in this one.
So much drama. So really lovely, Jerry.
That's well done, Jerry. That's beautiful.
Then since Mary is here, you know the drill, Mary.
Last week, and I was out.
From you, so.
Well, I was out in the freezing cold for an hour and 15 minutes photographing the moon, Saturn, and was it Venus conjunction? I can't even remember now. So yeah, it was freezing, and I looked up and saw an aircraft with lovely red sunset vapor trails heading straight for the crescent moon, and it couldn't have gone across more centrally if it tried. So this was just Sigma 300mm lens on my trusty 1100D that is 10 years old. So yeah, obviously the moon was low, the aircraft was all the way down over Fairford way. So the aircraft is tiny, but I couldn't pick between these 4 shots, so I've stuck them together. Just gorgeous. I love aircraft
Really
transits.
nice.
Lovely, absolutely beautiful.
Still you, Mary?
Yeah, it doesn't compare to the previous Orion Nebula we saw, but again, this is my Astro modded Canon 1100D on a William Optics 70mm refractor. So just 1-shot color. Yeah, outer region was 30-second shots and the core was 8-second shots, and I blended them together. So yeah, not tons of data, but I actually shot it in landscape, whereas I normally do it in portrait, and I quite liked that way round for a change.
That's lovely.
Really
Very
nice.
impressive.
Because the tricky thing about Orion is controlling the core, but you can still see the trapezium really nicely with the different exposures.
Yeah, I mean, I've only got Photoshop CS2, but I get by.
Really nice. And I think, is it you again? Yep.
Yeah, I mean, we've seen some really good versions of the Flaming Star in previous weeks. This is not one of them, but it's the first time I've ever tried to image this target, and boy, is it a pain to process. Honestly, I nearly just gave up and deleted it all. So, yeah, it's a pig of a target, and it was showing up really well in the individual subs, so I don't know why I was having such a problem. But 1100D again, Astro modded, and just 89 lots of 90 seconds. So yeah, and I reprocessed this literally 6 times, and I'm still not happy with it. But it just needs more data. It's actually fainter than you think, and yeah, I was glad I got a bit of the blue in there.
Yeah,
I can't remember how I did that, but I did.
Yeah, it's really hard. I mean, it's such a busy star field as well with this one, isn't it? But I remember, I think we got 9 hours on it, and it's still, to me, I was like, it was grainy, and it was one of those that I processed and thought, actually, it's not the processing, it's just there isn't enough data.
Yeah, well, and
people
people pulling me up on having star spikes on an image done with a refractor, but the truth was, by the time I'd messed around with this so much, I couldn't get around bloated stars, so I just shoved star spikes on to make them look better, because I figured that some fake star spikes is better than bloated stars, so that's why there are spikes.
It looks really natural as well. I really like the star spikes. So
I always go for subtle when I do add star spikes, but yeah, I've been pulled up about that on Twitter already. So
they're never satisfied. And then we're finishing up this week with the Cigar Galaxy by Andy. So he used the L Ultimate filter to bring out the hydrogen on this one. There's a lot more to get, so he's building up his integration time. But I mean, I'd still be really happy with that.
Oh wow,
that's incredible.
That's a nice one.
So
that's lovely.
really lovely.
Look at that. Well
Yeah,
done,
it's
Andy.
really, really beautiful.
It completely changes the band structure when you add the hydrogen and you like draw it out like that.
Yeah. Amazing. And that concludes our viewers gallery this week.
Well, viewers, as always, thank you so much for sending in your images. Keep them coming, because we do enjoy looking at them so much, and we know that our other viewers do. So thank you very much, everybody who's sending their images in. Some, really professional stuff. And as I frequently say, just a few years ago, the quality of these images from amateur astronomers would have been absolutely unthinkable. And it's not just the advances in the technology; it's people just spending a lot of time learning the tricks of the trade and coming up with the most amazing images. So hats off to you all, because I wouldn't know where to start. I've never really got into astrophotography. I'm more of an observer than a photographer. So
Rachel's been pushed backstage somehow. I don't know if you can let her back in.
Oh yes, we can do that. Yes.
Yay.
Rachel,
I didn't make the cut.
Yeah. So,
It'd be funny
I wonder who pushed you off that time. I reckon Daz is in the background. Yeah. It's Daz's revenge. So anyway, so we missed you tonight, Daz. But we hope that you can get your bandwidth problem sorted with BT very soon. It's been lovely to have Kareem back with us, and we hope you're going to stay this time, Kareem.
Try my best.
Yeah, I know. But thank you for being here, and thank you for your lovely Orion story. Thank you to Lou for your continuation of the Titan exploration story. Thank you, Bernard, for posing us a very interesting question. Thank you, Rachel, for the gallery. Thank you, Roger, for the night sky. Thank you, Mary, for your lovely images and everything else. And that brings us to the end of the program. We'd also like to say thank you to our sponsor, Rother Valley Optics. Thank you very much, guys, for your continued support. Rother Valley Optics in Rotherham, offering you anything in the way of optical equipment at very reasonable prices. So do consider them when you're considering making your next purchase. So thank you to Rother Valley Optics. We will, of course, return at the same time next week, 8 p.m. UK time, 3 p.m. Eastern time, for another edition of Space Oddities. Between now and then, we may see, as I said earlier, the first 33 engine static fire of the SpaceX Starship. Nobody actually knows whether they're going to have a launch platform existing after that, because they've never fired 33 engines before, and the most they've fired at any one time is 14. So it could be an interesting week. So keep your eyes posted for that one. If it's at a time when we can do it, I'd like to bring that live to you on Space Oddities. So do keep an eye on the channel. And because I know Daz, for one, and probably Michael as well, would love to cover that live. But we often don't get much notice of these things happening. And with SpaceX, they're a little bit reticent about announcing when they're doing things. So it'll be more by luck than judgment if we're able to bring that to you. But we will do our best. Okay, thank you all. Thank you all for watching. Thank you, everybody in Ireland. Thank you to Astronomy Ireland for letting us invade their Facebook page. Thank you to those watching on our own Facebook page on Facebook. And we will see you next time for another edition of Space Oddities. So from the panel, you want to say goodbye, guys?
Goodbye.
Good night.
And take care of yourselves. Have a fantastic week. We'll be back next Wednesday at 8 p.m.